All right, and we're live. All right, so we're picking up here with 8b. 8b. We got 22 x squared sine of 5x cubed e to the cosine. Oh, by the way, I wanted to say one last thing about this. Let's come back to part A that we already did. If you get really thorough, like before you start recognizing patterns, that last factor right there, you could have written it like this: secant quantity squared of 5 to the x cubed plus 7. And as I mentioned, if you work from the outside in, you might then think that the outside function is blob squared, which would turn into a power rule, right? 1/3 blob cubed. But that's why it's always important then to test what you would then call the inside function. Don't just assume it. Because if blob squared is the outside function, then secant of 5 to the x cubed plus 7 would be the inside function. And when you check it, what's the derivative of secant of blob? Secant blob tangent blob. And if you look outside there, you don't have another factor out there of secant blob tangent blob. So that would be the wrong choice of the inside function because it generated too many factors. You took too big of a bite. So now you try, instead of including the secant, you just try that. And now secant squared is the outside function. So little things like that. And that's why I call it pattern recognition. The more you work, the faster you can recognize those patterns. All right, so if we look at this one right here, maybe you don't need to start rewriting it every time, unless you have like radicals or something. You just put 22 in your final answer, right? What would you call the inside function? What would be u? Yeah, you could say maybe, let's do that. Maybe it's e to the cosine of 5x cubed. That would be inside something to the first. So it would be a power rule, 1/2 blob squared. But what would be the derivative of e to the blob? E to the blob. Do we have another factor of e to the blob out there? Nope. So that would be the wrong choice. Too big of a bite. We generated too many factors. So now maybe it's just the cosine of 5x cubed. And now maybe the rule of integration is e, which we know how to do that. So if we check, the derivative of cosine of 5x cubed is negative sine of 5x cubed. And since the inside function has its own inside function, it generates another 15x squared. And so if you compare the x squared sine part, we get that, and we're only off by a negative 15. So now we know we chose correctly. So 22 is already waiting in the answer. Joining him will be our correction of negative 1/15. And now the rule of integration. What is cosine of 5x cubed inside of? It's the exponent on the e. So it's the e rule of integration. What is the antiderivative of e to the blob? E to the blob, yeah. So e to the cosine of 5x cubed plus c. And then, of course, you can simplify. So, by the way, everything that we've been doing so far with this pattern recognition, it also works with u substitution. Everything that works with pattern recognition works with formal u substitution. Okay, so let's go ahead and review so far all the known trig antiderivatives. Example 9, the integral of sine of x is negative cosine of x. Plus c, thank you. Yeah, now we're done with that. The antiderivative of cosine of x, sine of x, plus c, good. Secant squared of x, tangent of x, yeah, plus c. Someone once asked me if we could say c plus tangent of x, and I'm like, addition is commutative. So, yeah, you'd be looked at a little bit weird, be like, whoa, that guy's putting c in the front. Take a step back. It's like he's got the flu or something. Yeah. So you can, I guess. I guess you can. I don't know. If you think you're going to forget it, right, put it first, get it out of the way. All right, the antiderivative of cosecant squared. Yeah, negative cotangent, good, of x plus c. Secant tangent, secant of x, yeah. And can you put minus c? Someone once asked me. I guess you can, but again, you want to be that guy? Right? I don't know, plus c. And then, of course, cosecant cotangent. Negative cosecant of x plus d. Could you put plus d? Again, stop it. Just stop it. Yeah, plus c. Capital C. Universally known plus c. Calculus students everywhere lose points for not putting plus capital C. So there you go. All right, so Of those trig derivatives, only the first two are straight up trig functions, right? Everything else is kind of some product of two or more, or I guess not more, just two. So sine and cosine, we know they're antiderivatives, but that leaves how many more trig functions out there that we don't know the antiderivatives of? 4. There's 6 total, right? 6 minus 2, 4. So after today, you'll know all 6 of them. So that's what we're going to do on example 9. We are going to derive the antiderivatives of the other 4 trig functions. And once we derive them, you're going to want to memorize them because you don't want to have to rederive them every time you need them. And then they become their own rules of integration for other types of problems. So the antiderivative of tangent of x is secant squared. No, that's not right. No, you have no. Just leave. You can't even catch up at this point if you think the derivative is the integral. I don't know where you've been. So what do we do? I mean, what can we do? Yeah, really kind of a reflexive thing to do is to put it in terms of something else, and the ratio identity is kind of a nice thing to go with. So what we've done now, and this is cool, we've turned it into 2 factors. We've been working with 2 or more factors. The next thing you could do, since you have a quotient, is to bring the one from the bottom to the top so that you could see layers. Now you have 2 options. When you bring cosine to the top, you could call it secant, or you could just say it's cosine to the negative first. I would say as a general practice, it's probably best just to keep it in its original form. At first, you might have to try both methods, but just say it's cosine to the negative first. So now that forces you to put parentheses, and it gives you an interesting exponent. So which of those factors now looks marginally more complicated or has more information? Yeah, the second one, right? So it could be, and this is a possibility, that the outside function, and therefore the rule of integration, is going to be blob to the negative first. But if that's the case, cosine would have to be the inside function. Let's see if it works. The derivative of cosine is negative sine of x. Yep, it worked perfectly. We got the necessary sine part. We're only off by a negative. So how do we correct it if we're off by a negative? Yeah, add a -1, right? Instead of dividing by -1, -1 is its own reciprocal. And so now the sign gets packaged back up, and it's time for the rule of integration. So blob to the negative first becomes blob to the 0th power divided by 0 plus c, right? We've done this before. You get up in the morning and you check your birth certificate. If it doesn't say Isaac Newton or Chuck Norris, probably Charles Norris, you can't do this, right? You can't do this. Can't divide by 0. So we remember, okay, in the singular time where the power rule fails, which is when you have your inside function in the numerator to the negative first power, or in the denominator to the positive first power, that would look like this. What comes to the rescue? Natural log. So this becomes the natural log of the absolute value of the blob plus c. And that is the antiderivative of tangent. If you want to write it a little more pretty, negative natural log absolute value of cosine of x plus c. So that's the one you're probably going to want to memorize. But there's another version that could be kind of useful. Because of the properties of logs, if I have a -1 coefficient, I could bring it up inside the absolute values as an exponent. Now, and this is important, this is cosine x to the negative first, that's the reciprocal. It's not inverse cosine or cosine. What is the reciprocal of cosine? Secant. So another version of that is positive natural log of the absolute value of secant. I don't think you need to memorize both of them. If you're going to memorize one, I would memorize the top one, and then just be aware of that little trick you could do. In fact, there has been a question on a former AP exam where it said, which of the following is equivalent to, and they gave you that. And this was the answer down here at the bottom. It didn't even really involve calculus. It was kind of a natural log property. Okay, so now the integral of cotangent. Kind of the same idea, right? We're going to write that as cosine over sine. Now I'm going to do this in a slightly different way. You could bring the sine to the top, but here's another way to think about it. cosine of x times 1 over sine of x to the first power, right? Just kind of separating them. Now you could say still sine of x is the inside function. What's its derivative? Cosine. There's no correction to make at all. We're not off by anything. So we can go straight to the antiderivative. Cosine gets packaged back up. And now the rule of integration is the following. What is the antiderivative of 1 over blob to the first? Natural log of the absolute value of the blob. So you have to decide for yourself which version do you think you would recognize the natural log in. It's x, 1 over x, sorry, or x to the negative first. But for us, maybe it's better as 1 over u or u to the negative first. Either way. Either way. All right, so the integral of cotangent now is positive natural log of the absolute value of sine. That's the one you want to memorize. But of course, there's another version. It would be the negative natural log of the absolute value of what? Cosecant, right. That one's kind of pulling a negative out of thin air, right? Calling sine cosecant to the negative first and bringing it up front. So both of those have two different versions, but I would just memorize the ones in terms of sine and cosine. Now those could easily be derived again if you forget them, because hopefully you still know the ratio identities. But then we're down to the last two, the integral of secant. Yeah, let's do what's been working. Write it in terms of sine and cosine. We get 1 over cosine. Oh yeah, oh yeah. Now here's what the losing person at the integration bee is going to do. 1 over cosine, that's like 1 over cosine to the first. I know that's going to be the natural log of the absolute value of cosine of x. Yep, plus c. I know not to forget plus c. And that'd be the same person in the spelling bee that goes cat, K-A-T. They are out of there. What did they forget to do? They forget to check, right? If you're going to call cosine the inside function, you better check yourself before you wreck yourself. What's the derivative of cosine? Negative sign, right? Do you see a sign factor out front anywhere to help us? Nope. So unfortunately that doesn't work. Now that wrong answer that I just had, that would make a great answer choice on a multiple choice question. Debate other people other than y'all. Y'all are extraordinary. Y'all wouldn't take the bait. So there's got to be another way to do it. Got to be another way to do it. We're kind of limited in terms of secant. It's not squared, so we can't use the PIDs. So this is going to require a slightly different approach. This one is going to require us multiplying by a clever form of 1. We're dealing with an expression here, an integrand, and so we can't change its value. So if we multiply by anything, it has to be equal to 1. If we add anything, it has to be equal to 0. So the question is then, what can we multiply by that's equal to 1 that will help us find the antiderivative? Is it 7 over 7? That's legal, but it's not impressive. Tangent? No, you could do a lot of different things and try them out. Now, the first person that came up with this probably tried a few things, or they were probably thinking what they wanted to have happen and work backwards. But it did take a little bit of trial and error, and we don't really have the time to do that. So Eric, I think, knew what it was. I don't know if you remembered it from last year or you just saw what it was. But it's secant x plus tangent x. And it's not that obvious right now why that works. But you'll see why it works, and then you'll be like, oh. Okay? So you almost have to like do that in your head before you come up with that, see that it works, and work backwards from there. That's how kind of genius inspiration works. So here's what I'm going to do. In the top, I'm just going to distribute, if you allow me to do that. Any objections? Okay, good. So secant times secant, that's secant squared of x. Plus secant times tangent, that's secant x tangent x. So that becomes the numerator. The denominator is just secant plus u tangent, bless you. And I'll just bring that to the top, secant x plus tangent x, and say that's all to the negative first power. Okay, which factor has more information or looks more interesting? They're both pretty interesting, right? So we really have two options. We can put that to the first. Let's see. Is secant squared plus secant tangent the inside function? Well, is its derivative secant plus tangent to the negative first? Nope, I don't think so. So maybe secant x plus tangent of x is the inside function. Let's see. It's two terms. What's the derivative of secant? Secant tangent. Plus, what's the derivative of tangent? Secant squared. Holy moly smokers. It worked. We are not off by anything. Addition's commutative. So the secant squared plus secant tangent gets packaged back up perfectly inside secant plus tangent. And so now we're on to the part two, the rule of integration. It's blob to the negative first. What's the antiderivative of blob to the negative first? Natural log, absolute value of the blob. Plus C. Yeah, I don't know. Sometimes inspiration comes, like when Kekulé decided that the benzene ring was a perfect hexagonal configuration. It came to him in a dream. He didn't have to do trial and error. Just there it was in his dream, and it worked. So. Right. You think they should, like, have their name attached to it. Like, instead of like calling that the integral of secant, you call that like Joe's integral, right? I don't know. All right, so now you can imagine how we would do cosecant. Very, very similarly, we would multiply by cosecant plus cotangent. So without having to actually do the work, you could probably predict, form-wise, what its antiderivative is going to be. Go for it. Negative, because it's cosecant, negative, natural log, absolute value of cosecant plus cotangent. Yeah, and that's it. Plus C. I'll squeeze it in down there. Yeah, plus C. So there they are. Those are the four that you now should memorize. We're going to quiz on Tuesday, and in part I'll have you regurgitate that to me, and then you'll work a problem that involves them. So memorize those. You have till Tuesday. All right, so just to review, tangent is negative natural log of the absolute value of cosine plus C. Cotangent is positive natural log of the absolute value of sine plus C. Those you just got to memorize and keep straight. I don't have a gimmick or a way to memorize those. But the other two, you're in luck. Here's why. What is the derivative of secant? The derivative of secant. Secant tangent, right? Secant tangent. Well, it turns out that the antiderivative of secant is exactly the same as the derivative. Secant tangent. With one tiny little difference. Instead of multiplying them, you're adding them inside the absolute values behind the natural log with a plus C at the end. Okay? Yeah, only one little difference. But other than that, it's the same. So since the derivative of secant is secant tangent, so is the antiderivative with all those little frills added, right? Same thing on cosecant. What is the derivative of cosecant? Negative cosecant cotangent. Well, you're in luck. The antiderivative is also exactly the same. It is negative cosecant cotangent. But once again, a little bit of extra. You're adding inside an absolute values behind a log with a plus C. But other than that, spitting image twins, can't tell them apart. Identical twins. Can't tell them apart. Okay? Now, believe it or not, that will help you with those two. You'll remember that secant is going to involve secant tangent. They all involve logs, right? They all involve logs. Notice the two that are cos have what type of antiderivatives? Negatives, yeah. And that's not true for cosine. Be careful. Cosine is just positive sign. But the other two, cotangent, cosecant, they're negative. So you can memorize those. And now once you memorize those, you can do problems such as example 11a. By the way, we just completed page 5 of 12. Huge, yeah, huge section. All right, let's see how we're going to do this one. 5, go save a place for us in the answer. Okay. So now we have x squared and tangent of x cubed plus 1. What's the inside function? X cubed plus 1, right? Possibly. Possibly. What's the derivative of x cubed plus 1? 3x squared, right? Not 1/3 x squared, Colin. Slow down there. You're kind of thinking about the answer. It happened last period. 3x squared. So we get the critical x squared part. We're only off by a 3, which is not a problem at all. We put a correction of a 1/3, and now we've accounted for both the 5 and the x squared, and we're on to step 2, the rule of integration. What is x cubed plus 1 inside of? It's inside of the tangent function. So now, what is the antiderivative of tangent of blob? Negative. Natural log. Absolute value. Cosine of, the blob. If it's more than plain old x, it's the blob. And then plus c. See, that's why you need to know what the antiderivative tangent is. It becomes now a rule of integration. And then, of course, you tidy it up. Negative 5/3 out front. Natural log, absolute value of cosine. What?
I said, honestly, it looks pretty much the same.
It kind of looks the same. I just, kind of forcing people to get together in the front there.
So, do you care which version you want to use?
Oh, no, I don't care. I mean, if it was a free response, that's the same also as positive 5/3, natural log, absolute value of secant. Yeah. They're both correct on the free response. Multiple choice question, though, they're going to have one or the other. They certainly wouldn't have both. So I don't care which one. By the way, since you brought it up again, these last two, you can't do that little trick with. If you put this negative up on the sum, cosecant plus cotangent, it just becomes 1 over cosecant plus cotangent. It does not turn into sine plus tangent. You can't just flip both terms. Okay? So it's not even worth addressing that. But it works for these single term dudes. All right, letter B, you go. Do it yourself. You can do it. What'd you get? I'll give you more time. Otters are anxious. Bless you. All righty. So here's what a losing player in the integration bee is going to do. They're going to be like, okay, blob to the first, so that's 1/2 blob to the second plus c, right? Yay, go me. All the way home right now. Can't play anymore. That's not it. Because then you're calling secant of blob the inside function, and the derivative of secant of blob is secant blob tangent blob, and there's no secant tangent factor outside. So again, that's picking too much. So hopefully most of y'all just went with e to the negative x. Can you try it out? What's the derivative of e to the negative x? Negative e to the negative x, yeah. So the 2 that's there, remember, he's already in your final answer. So forget about him. You're off by a what? A negative. So you'll have a negative correction. And now the antiderivative of secant is natural log, absolute value of secant plus tangent of the blob plus c. And of course, you just put the blob in there. And that's exactly the same as the derivative, as we said, of secant. There it is, secant tangent. All right? So now any trig function can be the outside function, and therefore the rule of integration. Okay, let's try some random integrals now to integrate all our integration methods. Oh, that's pretty clever whoever did that. All right, 12a, evaluate the following. I'm not going to do it for you because that would steal all your fun. This will be the last one we get to today, so I'll give you 2 minutes, and then I'll take 1 minute to go over it with you. Or we'll split it, minute and a half. All right, let's see what to do. We got something divided by something. So a good first step, if you don't see patterns right away, a good first step is to bring them to the top, so that, and then maybe force parentheses around the other one. So now you have the possibility of two inside functions. Don't forget your dx. If x is the inside function, it's inside something to the first. What's the derivative of x, though? 1, right? That's not x squared minus 4 to the negative first. So x is not the inside function. But maybe x squared minus 4 is the inside function. What's its derivative? 2x. Good. We got it. So we're off by a 2. So we have a 1/2 correction. The x now is accounted for. Rule of integration. What's the integral of blob to the negative first? Natural log. Absolute value. Good. Boom. And then plus c. So there you go. You could do that every time. If you have a quotient, bring it to the top, put it to the negative first power, and just choose. If there's more than one option for an inside function, check to see what the derivative of each is. All right? We'll stop right there. Memorize those 4 other trig integrals. Brush up on all your other integral rules. We'll pick up here on Monday. We'll quiz on Tuesday. Unless it snows like Sunday night and Monday's another snow day. Yeah, I doubt that'll happen. Now you get to go to another class that's not calculus, unfortunately. So try to enjoy.